Hello parents, this is Chris Allen. I'm your son or daughter's calculus teacher, and I wanted to give you a week update for October 19th. This week we are reviewing something called volumes, which I'm sure you're familiar with that word. And the example I'd like to show you just real quick today here is something called the shell method. So a region is enclosed by the curves y equals x and y equals x squared, and this region is rotated about the line y equals 0. Calculate the volume of the resulting solid. So first here, I'd like to just kind of give you an idea of what we're talking about here. If you look at the image that I just threw up, the two-dimensional image on the left, that's the 2D slice, if you will, on the XY plane. So you can see that the two curves, y equals x and y equals x squared, are on the plane. And then we're going to rotate those around the line y equals 0, which is another way of saying the x-axis. And we want to find the volume of that three-dimensional solid. So the formula here we're going to use is something we refer to as the shell method, because what we're basically doing is we're taking an outer radius disk and then an inner radius disk, and we're going to subtract those two volumes. So the formula is similar to the formula for the area of a circle, which is pi r squared, but now we're integrating some integration and some more complex ideas, obviously. So based on this formula, students got to come up with 4 variables to get their answer. They need to know what A is, they need to know what B is, they need to know what the big R function is, and the little r function. So let's start with the big R. So if I added this green rectangle here from the x-axis to the outer curve, which is y equals x. So that means that the outer radius, the bigger radius, big R, is the x function. Now this purple rectangle I just drew from the x-axis, that is of course going to be the inner radius, or the little r, and that is the x squared function. I should note that the two curves intersect at 2 points, when x is equal to 0 and when x is equal to 1, so A is 0 and B is 1. Now we can just plug all of this information into our formula, which is given above, and we get our final answer here after using the fundamental theorem of calculus to find the antiderivative, which is 2 pi over 15. That's the exact volume. So some final thoughts for this week. Number one, we just started our second 9 weeks. So if your son or daughter has done a good job the first 9 weeks, I would just encourage them, and you encourage them, please, to keep doing what they're doing, because it's obviously working. I would like to note, though, that starting next week, pretty much all of the content for the rest of this year will be new content. We will be done reviewing Calc AB. We are also on a new bell schedule starting this week. Obviously, they've probably already figured that out by now. What I would like to make sure I mention, though, is that remote students need to be aware of that bell schedule, too, because they are required to take assessments during the scheduled class time. So, for example, if your son is in my BC calculus class 4th period and his last name happens to be Allen, let's say, then he would probably be taking the assessment that we've got planned for next week, next Thursday, during that time period. And I sent them all an email about this just today, all the virtual learners. And then finally, discipline. I think that calculus in particular, and maybe any math class, obviously there's some intuition and some, I just get math things, but in calculus, a lot of success is just being disciplined. My best students are the ones that are very disciplined about not only getting their work done, but asking questions and studying, making sure they understand what's going on and doing extra practice. So thank you for your time, and I hope you have a great day.